where I look at the insects colonizing a dead body and then give the police some idea of when that person may have died, whether the body's been moved or disturbed, things like that. Obviously, because it's very difficult to do research in a marine situation.
A team of scientists lowered a dead pig into the freezing black water off the coast of British Columbia, set it down on the ocean floor, pointed a camera at it, and waited to see what the deep would do to a body. What that camera captured over the next 3 days is some of the most disturbing footage ever recorded on the seafloor, because the instant the pig touched bottom, the ocean reacted faster than anyone thought was possible. And the most unsettling part, this was only the shallow end. The real deep goes 10 times further down than this. Why a pig? The people behind this were Dr. Gail Anderson and Dr. Lynn Bell, two forensic researchers who study decomposition for a living. Their job is to work out what happens to a body after death and how to read that process backward to estimate how long something has been dead. On land, that science is solid. Insects arrive in predictable waves, bacteria follow a known clock, and an investigator can look at a body in a forest and put a reasonable window on the time of death. The ocean throws all of that out. Bodies get pulled from the water constantly, and nobody has a real framework for what happened to them down there. How fast did it break down? What fed on it? Were the injuries caused by an animal or by a person before the body ever went in the water? For a long time, the honest answer was that nobody knew, because you cannot exactly drop a human body into the sea to find out. So Anderson and Bell used the closest legal stand-in there is, a pig. A pig carcass is about the same torso size as a human. The skin is similar and nearly hairless, and the gut bacteria that drive decomposition are close to our own. If you want an honest answer about what the ocean does to a person, a pig is as close as you can legally get. The first experiment. The first round happened in Saanich Inlet near Vancouver Island, at about 100 meters down. 3 pig carcasses went down across 3 separate years, each one placed beneath a camera wired into Ocean Networks Canada's Venus Observatory. This was not some improvised setup. Venus is a permanent undersea station, cabled with live video and sensors that track oxygen, salinity, temperature, and pressure in real time, so the team could sit at a laptop and watch the seafloor around the clock. What they saw was grim, but mostly what they expected. Dungeness crabs, squat lobsters, and spot shrimp showed up within hours and went straight for the orifices and any open wound, pulling tissue away piece by piece. And then, on the second day of one deployment, something arrived that changed the whole picture. A huge chunk of the pig's hindquarters was gone, torn away in what looked like a single enormous bite. The size and shape pointed to one animal, a blunt-nosed 6-gill shark, a deep-water predator that can reach 5 meters long, carries 6 gill slits instead of the usual 5, and hunts almost entirely at night in water, so deep that people almost never see one. That one bite reorganized everything on the seafloor. It ripped the carcass wide open, and every scavenger in the area abandoned the natural entry points and swarmed the fresh wound. A single bite from a single shark had rewritten the entire feeding order, and it gave Anderson an idea that would nearly ruin her next experiment. Going deeper. So she went deeper. And before we go down with her, do me one quick favor. If you want to see what actually lives at the bottom of the ocean, subscribe, because this channel goes deep on exactly this. The strangest and most unsettling experiments people have ever run in the abyss. You are going to want to be here for the next one. The team moved the whole operation to the Strait of Georgia, down to 300 meters, past the point where sunlight gives out completely and the water turns to permanent black. The plan was simple: drop a carcass, let it sit for weeks, and film the slow work of decomposition. That is not what happened. Within 8 hours, a blunt-nosed 6-gill found the pig. Then a second one came. Then another. Multiple sharks tore into the carcass and devoured it so fast that the researchers captured almost nothing usable. Weeks of planned footage, gone in a single night. So they went back to the drawing board, and the rebuilt experiment is where they finally caught the thing nobody was ready for. The redesign. Anderson and Bell built a new platform carrying 2 pigs side by side. One was left fully exposed on the seafloor, the other was locked inside a barred cage, strong enough to keep the sharks out, but with gaps wide enough that smaller animals like crabs could still slip through. That cage was the clever part, because it let them separate the big predators from everything else, and finally see who was really doing the work down there. The whole rig sat under a camera, ringed with sensors, so every scavenger and every shift in the water would be recorded at once. Then they sent it down to 300 meters and waited. What happened next took only minutes. The swarm. Within minutes of the pig touching the bottom, the seafloor came alive. Thousands of tiny animals came pouring over the body. Lycion acid amphipods, pale and translucent, each one barely a centimeter long. On their own, they are nothing. Together, they are one of the most efficient flesh-stripping forces in the ocean. The footage showed the carcass vanishing under a living blanket of them. And when bigger animals like spot shrimp tried to move in and feed, the sheer density of the swarm physically shoved them out. In the fall deployment, that swarm reduced the exposed pig to a clean skeleton in 3 days. In the spring, it took 4. A body that would last weeks or months near the surface was bone in under a week, and the caged pig, protected from the sharks but still open to the small animals, let the team see exactly how much of that was the swarm and how much was the big predators. Now keep the way these animals work in your head, because they do not really cut a body up. They take it apart at the joints, and that one detail is going to explain something disturbing that keeps washing up on the beaches of British Columbia. We will get there, but first there was a bigger question. Why didn't the body just float away? The pressure. At 300 meters, the water pressure is roughly 30 times what it is at the surface, and that changes everything about how a body behaves. Near the surface, a body follows a familiar cycle. It sinks, the bacteria inside it make gas, it bloats, it floats back up, and eventually it sinks again. That bloat and float cycle is how a lot of drowning victims are finally recovered. At 300 meters, the cycle just stops. The pressure is too great for the body to fill with gas and rise. It stays pinned to the bottom. It never floats, it never drifts, it simply sits there and waits for whatever comes. And whether anything came at all, it turned out, depended on something in the water that the sensors were quietly tracking the whole time. The oxygen twist. That something was oxygen. When the dissolved oxygen in the water was at normal levels, the sequence ran like clockwork. The big scavengers came first. The sharks and crabs and shrimp opened the body up, and the amphipods flooded in behind them to finish it. But when oxygen was low, the big animals stayed away entirely. And here is the strange part. On their own, the amphipods could not break through intact skin because their mouths are not strong enough to make that first opening. So in low oxygen water, the carcass just sat there, nearly untouched, breaking down slowly from bacteria alone. The difference between a body stripped to bone in 3 days and a body sitting eerily intact for weeks came down to nothing more than how much oxygen happened to be dissolved in the water around it. Think about what that means for anyone trying to read a body pulled from the deep. 2 identical bodies, going in at the same depth on the same day, could end up telling completely different stories just because of the water they landed in. And as unsettling as that is for a pig, it is only a preview of what the ocean does to something far, far bigger. The whale fall. When a whale dies and sinks, you get one of the strangest events in the entire ocean. Scientists call it a whale fall. A single whale can weigh anywhere from 30 to 160 tons. And when all of that flesh and bone hits the seafloor, it becomes an entire ecosystem on its own. Hagfish and sleeper sharks get there first and strip the soft tissue over months. Then the crabs and polychaete worms and snails move in and pick the remains clean over years. But the last stage is the one that will stay with you. Once the flesh is gone and only the skeleton is left, a creature called Osedax moves in. The name is Latin for bone devouring, and the common name is worse, zombie worms. They were only discovered in 2002, and they have no mouth, no stomach, and no gut at all. Instead, they drill into the bone with root-like structures that secrete acid, dissolving the skeleton from the inside, while bacteria living inside the worms digest what the acid releases. They eat bone without ever taking a bite, and a single whale skeleton can feed communities like this for 50 to 75 years. The pigs Anderson dropped were tiny next to a whale, but the lesson was identical. The second anything organic hits the deep seafloor, the ocean switches on. And that brings us straight back to the detail I told you to hold on to, because it is the part of this research with real consequences for real people. The feet on the shore. For years now, something has been washing up on the beaches around the Salish Sea. Detached human feet, still laced inside their running shoes. Every time one turns up, people jump straight to serial killers and dismemberment. Anderson and Bell's work points somewhere much stranger. Remember how the scavengers take a body apart. They do not cut through bone. They eat away the connective tissue at the joints, the weakest points, until the body simply comes apart at the seams. A foot sealed inside a light, buoyant running shoe can separate from a decomposing leg on the seafloor, float to the surface, and drift to shore. No violence required at all. Modern shoes, with their sealed foam, float far better than the old leather ones ever did, which is part of why this keeps happening now. The ocean did it, and there is a darker edge to it. The damage these scavengers leave behind can look exactly like human violence. A shark bite can be mistaken for a stab wound. Crab feeding can look like deliberate mutilation. Without understanding what the deep actually does to a body, an investigator can look at plain natural scavenging and see a murder that never happened. The real deep. So, step back for a second and remember where all of this happened. 300 meters. Because here is the thing that should genuinely unsettle you. The average depth of the ocean is around 3,700 meters, and the deepest point we know of, the Challenger Deep, drops to nearly 11,000. The pigs in this experiment were sitting in the shallow end, and even there the response was instant and total. Now go 10 times deeper, 3,000, 6,000 meters down, where the pressure would crush a submarine, where the cold sits just above freezing, where no light has reached in millions of years. The scavengers are still there, still patrolling, still waiting. The deep ocean is not empty and quiet. It is packed with things that are very, very good at making other things disappear, and they are patient, and they are always hungry. So, subscribe if you want to keep going deeper with me, because there is a lot more down there than one pig. And I want your answer in the comments. If you could drop a camera to any depth in the ocean and watch what came for the bait, how deep would you dare to go?